Okay, we're going to go through this example that's taken from the textbook on page 599, and unfortunately my pen doesn't work and it's the weekend, so I can't get any help from IT. So I basically, it seems a bit strange, but I've just put some boxes over the top of it, and I'm just going to go through it step by step with you. If you don't need me to do this for you, then please, ignore it completely. However, sometimes it's nice just to see what steps are involved. Okay, so let's pretend we haven't got anything down at the bottom, and we've just got our starting question, which is about Sue, boiling water, and so on. All right, and what we're trying to do is use the formula, which is obviously quite complicated looking, but if we take it step by step, we can fill in these pieces. All right, we can use the TI calculator. However, when we do our internal assessment, you will have to be able to do all this by hand. So I'm going to go through it with you now using this example and see what you think. Okay, so first thing to do is to set up a table, and in the table you will need to put your x's and your y's. Alright, and you'll see from there the volume called x, because we're saying as the volume increases, what happens to the time to boil. So the volume is the independent variable and the time is the dependent variable. Okay, anyway, we'll just set it up, and notice there's only 4 bits of data. If we did it with 20, it would take so long. So just let's get the idea across. So you need to set up a table up with your data in, and notice we're putting totals pretty much all the time to fit the formula. Alright, the formula looks like that, and so that's where we're heading towards. Okay, so if you have a look, you can see various bits. It's x, y, x squared, and so on. So let's take the next column off and say this is x times y. So 1 times 3 is 3, 2 4s are 8, 4 6s is 24, 5 8s are 40. Add them all up, and there's your sigma xy. Alright, sigma xy. Okay, now your next lot is you need to know n. Well, n is not 8, there's actually only 4. If you were to plot these, and there is a graph down here, if you were to plot these, you'd only get 4 points. Okay, and now there's 8 obviously numbers there, but there's 4 pairs. Alright, so n is 4, which is this part here. We now need x bar, and we've seen x bar before, means the mean of x. Alright, so we're going to add them all together, which is what we've already done, and divided by 1 2 3 4. Okay, so there is x bar, sum of x divided by n. 12 over 4 is 3. Similarly, we've now got y bar, which is the mean of y, same thing. Alright, and you're now at that point there. If you go now onto the denominator, we've got the square root of x squared. Alright, x squared. So go back to your table. We know what x is, but we need now x squared. So 1 times 1 is 1, 2 2s are 4, 4 4s are 16, 5 5s are 25. Okay, and you'll notice again later there, look, you'll need y squared, so let's put that in, and there's your table. Alright, all done, and those are your numbers there. Now the bit that might be confusing is this n's alright, but it's this x bar, well, it's x bar squared. Okay, so x bar is 3, so this would be 3 squared. Let's reveal the next panel, and what we're doing is going to substitute all those numbers in, and I'll go through it with you now. Alright, so we've got the sum of xy. Well, the sum of xy is 75, right there. Take away 4 n times x bar times y bar. So there's your numerator done. All over the square root of the total of x squared, which is 46, take away n, which is 4, and this is the bit, as I say, that looks a bit confusing. It's simply the mean of x squared. Now you notice that in the example it's all typed out nicely for you, and that's what you should be doing. You should be writing out and filling in the substituting in the numbers into the formula. Don't try to do it all in one go. Okay, continuing through, you've got y squared, which is over here in your table, take away 4 again, times, yep, y bar, the average of y squared. Once you put all that in and tidy it up, you end up with an R value, because we've done all the necessary work there, of 0.988. Okay, now from what we can see before in class, that is pretty close to 1. Okay, and so we can comment upon that, and that's important there. It's pointless having an R value if you don't actually do any commenting on it. Alright, so we're saying it's positive, so we get the idea anyway. The more water you have, the longer it will take to boil, but since it's close to 1, there's a strong positive correlation. Alright, done.